Hey, manufacturing world, welcome to another episode of Shop Matters, sponsored by Okuma America. This podcast is meant to talk about all things manufacturing related. I'm your host, Wade Anderson, here in beautiful, sunny Charlotte, North Carolina. And today in the studio with me, I've got Jeff Estes, a longtime friend of Okuma and head of one of our partner companies, Velocity. Welcome, Jeff.
Oh, glad to be here. Thanks for having me and really appreciate just the opportunity.
Well, Jeff, tell us a little bit about who is Jeff Estes.
Oh, boy, that's a loaded question. I'm just going to tell you, that's a loaded question. I've been in manufacturing my whole life. So manufacturing
So like 5 years?
Oh, yeah, at least, yeah. But when I came out of college, I went directly into manufacturing. In fact, I was working in manufacturing as I was working through college, and just making parts is just wonderful. And CNC world is just the dream. I mean, how in the world does a machine cut steel and metal and Inconel and titanium and all these crazy materials? How does a machine do that? You know, It's just, and I don't want to give away my age, but let's just say after 40 years, I'm still amazed.
Yeah.
Just amazed. Yeah.
That's excellent.
Yeah.
What do you do for Velocity? Talk about your role within Velocity and what is Velocity as a company?
That's a good point. Velocity, it makes CNC machine tool holders, mainly for lathes. We make rotary tables for machining centers. But our bread and butter is really our tooling, both the live side and the static side. We bring this out of our supplier out of Italy, which a lot of people would know as Sumatic, and we are the North American distributor of that through Velocity. So, and we only do Okumas. So you won't see our tools on any other machine type except Okuma. And it's been a great marriage and a great relationship that we have both with Okuma and with Sumatic of being able to bring that in and really focus on that. My role is I'm the general manager of it. I have responsibilities for all North America. I have territories that are assigned to me that I do directly as a salesperson, but also have general responsibilities as well.
Okay. So Sumatic, I know, is going through some changes in, is it Italy or Switzerland? Where did they add? They built new real estate?
That's great. Where our home, our big company is Schooner, which is in Switzerland, but Sumatic is based in Bologna, Italy, and building a new facility. We're tripling the size, should be open next summer. So that building is under construction. For everyone, the Italians do everything in square meters. I'll just convert it. It's roughly about 50,000 square feet. So they're going from about 15,000 square feet to 50,000 square feet. Added in capacity, use Okuma machine tools to make our product. So just really
So I got a story
amazing.
I got to share on that.
Yeah.
So probably about 5 years ago, I had the opportunity to take a trip to Sumatic on behalf of Velocity and Okuma to learn more about their manufacturing process, what their capabilities are. And it was my first time to be in that part of Italy. It was a beautiful trip. I've been to Switzerland a couple of times, phenomenal place. My first time going to Italy. So we toured all the facilities, saw all the manufacturing places that you guys have over there. Then we go to dinner. And certain things, I'm a country bumpkin. It amazes me sometimes, when the light bulb clicks and you realize where some of this comes from. But we go to dinner at a place where they do a lot of wild game, wild animals and stuff. And one of the specialties come out. It was pasta with this meat sauce. And I'm looking at it, and it was a Bolognese sauce. Like Bologna, Italy, Bolognese. I got it now, right? All my life I never really put that together. Then they come out with this meat, and it's sliced up, and it's laying on a plate, and I'm looking at it. Like, that looks just like bologna. And then again, the light bulb goes on, Bologna, Italy. That's exactly what it was.
Yeah.
A very high-end version of it, but yeah, very interesting. So we have a great meal. The guys, Avanis and the team over there, phenomenal hosts to begin with, but had a great meal, enjoyed a lot of laughter and good times. And then he said, "Hey, I've got something special I want to show you." Okay, so we all pile in the van, and we go back to the manufacturing plant. And we walk in, and literally it's pitch black, completely dark, and you walk in the shop, and Ivana's kind of leading the way to get us in there, and you could hear machines running. You could hear the turrets in dumping. You could hear the pallets going in and out, but the entire shop literally lights out. I mean,
Absolutely.
completely black. And then they flip on the lights, and you see they're running everything in a lights-out operation.
Right.
They do a state-of-the-art manufacturing facility. Talk a little bit about their production and how they approach manufacturing what they do.
Yeah, it's a great point, and lights out is very important especially for the Europeans. But when they approach manufacturing, it's very engineering and manufacturing driven. They're looking at the market, but then they are engineers at heart, and they're looking for how do you make a reliable product that's going to perform and stay out in the field for a long time. We can say sometimes that the products are too good; they last too long. Same way with Okumas, they sometimes last too long if you look at it just from a marketing standpoint. But they're looking for longevity, how people will use it. And then in there, they use Okuma machines to make the product. But they also use the products that they make on those Okuma machines to make more tool holders. So they're testing their product on the machines that we would sell them to and market to here in the U.S. They're actually being tested every single day in the factory, just making actual parts. So it's a philosophy of how do you make it better, how do you build it better, and where do you know where the failures are. And I know a lot of people don't like to talk about failures, but everything's going to fail at some point. Engineers talk about FMEAs and trying to plan it out. We compare the FMEA to the actual because we're using it. And now we know what conditions does this run best under, what conditions does it not run best under, and then we're able to communicate that to the customer, and then we're able to try to design around it to how do you make that better and how do you strengthen that weak point. It's an interesting thing, but like you said, first of all, your dinner probably lasted 3 or 4 hours because they eat multiple courses. I mean,
that was an event all to
That's
itself.
exactly right. There's no such thing as a 3-course meal. It's more like an 8 or a 10.
Right.
And you think that you're done after 2 or 3 and you're all full, and they say, "Oh, we're just getting started."
Yeah.
And then they take you back and go into the facility, and it is usually late in the evening. So yeah.
You brought up something. I'm going to get a little bit off topic here, but talking about failure. It's such an important learning tool as well. And one of the things, I had a mentor and a philosophy that I was taught a long time ago when it comes to leading, leading in an organization, leading in anything, whether it's life or your business. There's an acronym SAOF, and that's schooling, apprenticeship, opportunity, and failure. Yeah. And you can't be a good leader unless you've mastered all 4 of those. So you have to have schooling, you have to have head knowledge, you have to apprentice with somebody who's been there and done that, where you can apply what you've learned, from the schooling aspect. And, he teaches you the school of hard knocks along the way as well. Then you have that opportunity. You have to have the opportunity to lead or do something substantial. And you got to fail. You have to fail, and you have to learn lessons from it. So people talk a lot about, like you mentioned, you don't want to talk about failure, but failure is a big tool that you can use to advance what you're doing in life and in business.
Yeah, I would say something that I've shared a lot through my life is the only people that haven't failed are the people who have never tried anything new. It's just part of our learning process, and we try, as you say, to learn from the tools that we're given from books and from prior knowledge, but that application.
Yeah.
You gotta put rubber to the road at some point. And then what did you learn from that? And if things didn't go the way you want them, great. Okay, where were the areas that you did well in?
Right.
And then where were the areas that you could improve in? And that's part of that process, and that's that longevity process that you learn. And Somatic does a really good job of that in our tools. And Velocity, Okuma, been in business since 1898. I would say they probably had 1 or 2 failures, and
certainly,
in that time. But look at them. I mean, it is in my opinion, the premier machine tool in the world, and just that longevity and learning and improving the constant. So
When you look at like what Velocity is doing, where they're using the tools that they're manufacturing in their manufacturing process, they get to see the strengths, the weaknesses. They can make design improvements based on that. We do the same from an Okuma perspective. We use Okuma machines to make Okuma machines. And because it's in a manufacturing, and we're very much a lights out operation in Japan as well, there's things that we learn from that, and new chip conveyor designs, because we machine a lot of cast iron in Japan, obviously. Well, cast iron is nasty, sludgy
sure
material. Well, we learn lessons from that, and we apply those. We re-engineer our own equipment to have better reliability and longevity. One of the biggest costs to any company is downtime. So how do you prevent downtime? Well, you got to re-engineer, redesign things, make it better. And that constant improvement loop, that loop cycle that you're working through. So
yeah, and you said something earlier too. You were mentioning lights out.
Mm-hmm.
Okay, if you think it's hard to monitor things when you've got someone watching the machine, think about what's happening when you're not there. Whether you're getting 2 hours, 4 hours, 8 hours, a couple shifts, a shift and a half, that machine logic has to tie in where, okay, this event happened.
Mm-hmm.
What's my next step? What do I do? What's my fallback? Do I have redundant tooling? How do I address this? And all that logic comes into play and lights out. And that's part of the process that we use in our manufacturing is, okay, this happened, this tool failed, or we got too much load on it. Mm-hmm. Well, we should have a redundant tool that we can go to. And the machine's smart enough to tell us, hey, that machine's expiring.
Right.
Okay, so you've got to link to that, and then if our tool holder fails, where it's overheated or something, well, guess what? We're throwing more load on the turret or on those drive systems. The same system, the same message is coming back on. This isn't working the way it should. Something's happening here. So
right.
You learn all that from doing lights out. I mean, we can talk about it, but until you do it,
right.
Oh wow.
Yeah, you can practice boxing all you want, but until you got your nose bloodied, you don't really know how to box, right?
Yeah, I'm a really good golfer on TV, but get me out on the golf course, it's a whole different story. So,
Excellent. So, Jeff, obviously we know Velocity from standard type products, pull studs, our turret tool holders, live tools. You guys also do a lot from a special standpoint. We utilize your engineering horsepower with special applications, special projects. Talk a little bit about what does Velocity bring to the table from an engineering perspective.
Yeah, one of the things about engineers, they do not like to do the same thing day in and day out. It's just inbred in them. They love to design stuff. They like to try different things and something new. And being an engineering company, we like to make specials. Mm-hmm. And a special that we could talk about is going into deep pockets of a product.
It's like a aerospace case, engine case, something like that.
If you think of companies who make large valves or some type of aerospace component where you have to do cylinder work,
blowout preventers.
That's exactly right. So the Okuma machine tool, and let's say it's a large machine tool like a VTR, the head and the ram actually can't go down into some of these areas. So you have to put some type of extension. But these customers want to have driven extensions, so they want to drive the part and maybe do a right angle.
Right.
So they go. An example would be they go into a 7 or an 8-inch bore, and it may go down 20 inches, and then they want to machine some type of feature at a right angle inside of that. Well, we make tool holders for that, special tool holders to do that, and understand if Okuma can throw 100 Newton meters or 600 Newton meters of torque, we can't transfer that much in there.
Yeah.
It just can't happen. We can't transfer 80 or 100 horsepower. But that's not the type of feature that you're doing deep in those pockets. But it has to be accurate. It has to be dead nuts to a perpendicularity or a parallelism or something very critical, or a cylindricity or something that's very, very critical. That's where we love it. We love it when somebody says, this isn't an easy one. And we're going, our eyebrows raise right then, because it's fun at that point.
Okay.
And so that is part of our company.
So you mentioned the VTR for an example. It's a ram style spindle. What kind of connection are you guys using?
We actually buy a curvet coupling adapter from Okuma. We integrate it into our tool. We align it at the factory.
So you're using the same
That's
coupling
exactly.
system we would run on our attachment heads.
We actually buy it from you.
Okay.
so,
All right.
so we make sure it is compatible and it works. And then we do the alignment. And then the only thing that the installer has to do is the fine alignment. You know, the doing that fine tuning, those 5, 6, 8 microns that they have to bring it in. But there's none of this spending all day trying to get it aligned. That's already done. Much like your heads you already have on those machines.
Okay, excellent. So, what do you see the future being in manufacturing? You know, I always like anytime I do these podcasts. What do we do here? What do we do now? What stuff guys can take advantage of? But look out on the horizon. What's the next 5 years look like? Where do you think we're going to be 5 years down the road?
You know, and we've been talking about this for a while in the machine tool industry. Multitasking is just being able to do more on the same machine. That's becoming more and more important.
So why is that? I mean, I know, but for people who aren't, you know, maybe used to doing 2 lathes in a milling operation, you know, I know in my heart why I want to go to a multitasking, but what is it from Jeff's point of view?
Well, it's really simple. You're trying to hold all your tolerances in one work holding. And you also don't want to have to have 3 or 4 machines. You've got one machine that's doing different functionalities and different functions. So you don't have 3 or 4 setups. You got one setup. You got one set of work holding. So you don't have to buy chucks or fixtures for a lot of different machines. And the last one that nobody really talks about, but the accountants really love to talk about it, is the WIP, the work in process. So you're moving product through. Your throughput time is more consistent and more smooth. So you're not building pockets of WIP that are sitting here idle that you've got X number of dollars invested in. You're able to move that product through. So there's a lot of advantages, but from a quality standpoint and from a lights out standpoint, which we talked about earlier, multifunction machines work perfect in that because you may not have a 2-minute cycle. You may be trying to do an hour and a half worth of work, and you're doing it on one machine. Guess what? That machine's doing it. What can you do in that hour and 15 minutes that's open to you? What other functions and actions can you do in work? So a lot of things are really good about trying to do multiple tasks into one. Okuma has various levels of machines. I think that a lathe with a milling function on the turret is a multifunction machine because it's taken a typical turning process and now you're getting milling functionality. And that's about as simple as it gets. And then it can get pretty complicated as you go into the 5-axis machines, the multises. Absolutely.
Right.
But they all build upon each other. And really, that's where people are going.
I did an exercise. I was going to present at IMTS. Of course, now IMTS is going virtual. It's IMTS Spark. So if anybody hasn't logged in, check it out. You know, Google IMTS Spark and put your credentials in. You can see pretty much everybody that was going to be at the show now in a virtual environment. So now my talk is going to be a webcast instead of a live presentation. But I put together a spreadsheet a long time ago working through how much does it cost to make a part. And over the years, I keep adding to it. And the biggest thing that I've learned, it's a very complicated spreadsheet to, you know, if I showed it on the screen, it's very busy. But once you work with it a couple of times, you realize there's only a few variables that you have to tweak. And you can see a massive swing at how much it's going to cost you to make that part. And invariably, almost every process I've looked at, the labor component of it is what really swings how much your part is going to cost you to produce. And you look at how much you're making it versus how much you're selling it for. And then, okay, now how do we, you know, if we can't raise our sell price, how do we reduce our cost to make it? And a lot of times that becomes keeping that spindle running, getting your productivity up, or having unmanned lights out type operation, which, you know, we've been talking about. So there's some unique things people can do with the machines they've got. Being creative with their processes. And that's where I think, kind of circling back to some of the specials and tooling that you guys make, you there's applications we'll look at and we'll automatically gravitate towards, well, you need a multis, you need a machine with a B-axis head to get to some of these angled holes and things like that. But in reality, we can do some of that on a standard, single or twin turret lathe using angled tool holders and things like that. Do you talk about some of the tooling you guys make that would address issues like that?
Absolutely. Let's just take, if you wanted to do a right angle mill on a lathe and you wanted to mill something on the OD of the part, we've got tool holders that can do that and can transfer a lot of force.
Mm-hmm.
But the one plug I have to give, you better make sure your machine tool can handle that opposite force being pushed against it, or you're not going to hold the tolerance that you want.
That's have the whole system.
That's exactly right. So you start looking at everything. How does it fit together, and can that machine tool lock? Can it stay in a position, or can it hold that position and exert that much force? Hobbing. 10, 12 years ago, we didn't hob on lathes. You had a special hob. Now it's very, very common, but the force that's being put back on the machine tool is amazing. It's huge. The force that's being put on our hobbing tools to be able to do that and to make a good quality gear tooth or spline. Broaching. Who would have thought about broaching?
Yeah, so that was something I was going to bring up. I think about we've done broaching operations on machines in the past where you're basically shaping, the shape. But for us to do it on the machine, you got to program a Z move, X move, Z move, X move. So to step your way into a tooth depth, you're doing this box shape over and over and over, and putting a lot of wear in a small, centralized location on the machine. But you guys actually make a broaching tool now.
We do.
All that's built into that system. So we're really just feeding in the X-axis then.
That's right. You feed to a position and you lock there, and then we take it from there with our stroke up to 65 millimeters or 2.5 inches. That we can do a stroke, OD or ID, and we can go in and actually it is shaping. So we can shape splines, shape gear teeth, or do slots, do keyways, whatever you want into that part. And the beauty of it is, although broaching tools aren't cheap, they're a lot less expensive than replacing a machine drive or replacing a ball screw or a guideway on a machine tool. So we're putting wear on a smaller component that actually can be expendable, and you buy another one and you replace it, and it extends the life of the machine.
Right. Protect your more valuable asset.
That's exactly right. And let's face it, the tool holder in many cases will take the force of a bump. People hate to call them crashes, but let's just say a bump. And that force, a lot less of that force is transferred into the machine, so you don't damage your machine. You may just ruin the tool holder. And you may lose the cutting tool itself, but that's easy to change, and it's easy to get back up and into production too. So again, our tool holders are somewhat expendable, and we're trying to keep the costs down to where if a bad thing happens and you didn't mess up your machine, very quickly, if you have another tool holder, you get an exchange from us or a replacement, we'll ship it out and you should have it the next day. You're back up and running and you're back into production. So.
Very nice. Now, a new product that you guys introduced, was at last IMTS, I think, was the 4th-axis rotary tables.
Right.
So that's a whole new segment of Velocity's business. So now kind of not only being a valuable supplier from a lathe standpoint, but now you're getting into the mill arena. So
that is correct.
Tell us a little bit about the 4th-axis tables that you guys build. I know there's a huge design time frame that went into this, and talking to all of our distributors and trying to build something that everybody was requesting and meeting all their needs.
Yeah, and we actually went high end. We did not focus on the lower end on the rotary tables, and there's pluses and minuses to that, but we definitely went on the high end side. We stayed at 200 millimeters just to try to the face, trying to get to where people can use it on an M560, an M660, the new Genos M660, M460. It really fits on all three of those models well, and we only provide it for Okuma. So we've got Okuma direct drive motors in there and driven from the Okuma drives. So It is designed to try to maximize the capability of the machine as far as its repeatability and its capability. It doesn't really care if you're cutting aluminum or Inconel. It really doesn't care. And it was designed that way. It was designed to whatever you want to throw on it in material, it can take the load. The brake system is a much heavier brake system than what you'll see on our competitors. We have 3 discs instead of 2, just to hold it in position. So instead of relying on a servo motor to hold it, we actually have the brake really doing holding all the force. So,
excellent. So you guys really matched Okuma's design philosophy.
Yeah.
You know, we build a premium machine that can tackle a wide range of materials. So people ask me all the time, do you produce a machine that'll cut aluminum? Yeah. Do you produce one that'll cut titanium? Yep. It's the same machine. There it is. You know, now you get into bigger horizontals, we may have different spindle RPM ranges to tackle different applications, but the frame of the machine is designed so that we can do heavy hogging type work or high speed, high dynamic work, because we build the mass behind the machine to be able to handle anything that's thrown at it. And you're really doing the same with that rotary table.
That's right. And for people who are job shops they may not know what they're going to make next week. They may be making aluminum this week, and then next week somebody comes in and says, hey, I want one part, very special item made out of titanium. Well, they're not going to go out and buy a new machine and all the tooling and everything else. They're going to try to use the machine that they've got. So as Okuma designs their machines for all those, so is our rotary table. It's designed to take that load and that force. Sometimes products actually hit harder to machine components than it does the easy ones, because you also calibrate the backload, the opposite force, and you calculate that in. So we have to run that fine line. How do you calculate accuracy and position accuracy where you don't have a lot of back force, but then the next part you run, you may be running a material that gives you a lot of opposite force.
Right.
And it's always an engineering a task to try to do that. So we designed it to fit whatever Okuma's can make. A rotary table can handle it. We can't handle all your power. So for those of you out there that are in job shops and you're going, oh, great, it'll handle 50 horsepower. No, I didn't say that. It is a 4th axis. So, but just like a 5-axis machine or that you would buy, as you move more and more axes, you lose more and more force. But we can handle a great load on it. So,
right.
Yeah.
Excellent. What's the best way for people to learn more about Velocity and the products you offer?
Well, there's several ways. First of all, you can go to Velocity Products or just the Velocity website, and you can see any product that we have. You can go on LinkedIn. You can type in Velocity or Suhner, Suhner, and you can get all kinds of information on our mother company that's making the product back in Italy. So you can go in their LinkedIn page. Obviously, you can contact us through salesvelocityproducts.com, or you can contact any of our sales guys or our distributors. Okuma distributors are our distributors. So any Okuma distributor, you can contact them. We are a member of Partners in Think, so you can always contact Partners in Think. Wade being the head of Partners in Think, just contact them or the technology centers, and you can get information or get to us. I promise you there are some questions that none of us can answer immediately. Okay, that's part of that learning process.
Sure.
But we really do like those questions.
Yeah.
So please bring them, because that's the engineering part of it.
Bring you the hard stuff.
Well, we like that. The easy stuff, I mean, that's one thing. But the challenge is what we get up for every day, and we really like. So, and we'll get a group together. We'll, even in this world, we'll bring people together through Zoom or Microsoft Teams or whatever, and we'll have conferences just to go over things. And customers love that. You know, they can talk to us through it. So.
Isn't that, I was talking to John Toohey on another podcast, and we talked about how the whole virtual environment, you know, the navigation through the COVID world now has forced us to utilize Teams and Zoom and tools like that. And it really makes the world a much smaller place. I know, just speaking between us, we had a meeting with Ivanis and Patrick in Switzerland, and that was pulled together in 5 minutes of, hey, we need to have a quick roundtable discussion, fired up a Teams meeting, and next thing you know, you're in a different part of the country than I'm in. I was at home in South Carolina. Ivanis and Patrick were in Switzerland. And that quick, we were all online, face-to-face communicating. And it really makes the world a small place.
Yeah, and it's not just talking, too. We were doing a Zoom, very, very similar to Microsoft Teams, with a customer and doing the same thing with people in Italy and Switzerland. This customer was in New York, and of course I was in my area in South Carolina. And I had all the drawings on my PC in South Carolina, but I gave access to my PC to everyone, and we had engineers in Italy and engineers in New York playing with those drawings, modifying those drawings on my little PC in little South Carolina, and it was just amazing. You know? And when we got off, as I was leading at the host, the customer made a comment as we were getting off. He still had his microphone on. He says, "That was really cool," you know, and that's what you want. You want that ability to get customers and the designers and the company together talking to meet their needs. So it's part of our future. This isn't going away. We've learned some stuff about being able to do conferencing, and it's really good. There's no substitution for face-to-face. But we don't have to do as much face-to-face as we had to in the past. We can do face-to-face on using other technologies as well. So
excellent. Well, Jeff, I really appreciate your time today. Thank you for joining us on this episode of Shop Matters. If you have questions, ideas for future podcasts, please reach out to us. You can find me on LinkedIn, Wade Anderson on LinkedIn, or you can reach out to us on okuma.com/shop-matters. Till next time, we'll see you then.